Good evening, everybody. Let's start our today's discussion on medicinal chemistry, week 6 assignments, and the probable answer and explanation of the questions. Is my screen visible? Okay, let's discuss our today's first question. That A statement is given here. We have to say it is true or false. So, drug 1 is 98% bound to a plasma protein. Drug 2, which competes with the drug 1 for its plasma protein binding site, it's administered. 1% of drug 1 is displaced from the proteins by the drug 2. As a consequence, the free unbound concentration of drug 1 is increases by 50%. So is this true or false? Am I visible? Sorry, am I audible?
Yes,
Okay. Can you see my screen?
yes,
Okay. Okay. So anybody wants to answer this?
yes, it's true.
Yes. How can we explain it?
As it detached from the proteins, it becomes free and therefore it is free to becomes active to show the action.
Yes. So let's suppose it is the drug 1. It is in the plasma membrane bound state, and this is drug 2. Okay. So when it approaches to the plasma membrane, some of its parts, some of the drug 1 is released from the transmembrane domain. So before administration of the drug 2, 98% of the drug 1 was bound, right? And 2% was free. Okay, so total 100%, 98% was bound to plasma membrane, and only 2% of the drug 1 was free. Okay, so when we are adding drug 2, right? So the unbound concentration of drug 1 is increasing. 1 percentage of the drug 1 is displaced from the protein by the drug 2. So previously it was 2 percentage in the active state, in the free part for the admins for the circulation, and now 1% of the drug 1 after adding drug 2 is displaced from the protein. So now the free percentage, what, previously it was 2 and now it is increasing by 1 percentage. Then how much is free now? Drug 1, previously 2 percentage was free for the circulation. Now after adding the drug 2, which competes with the drug 1, its plasma protein binding site is administered, 1% of drug 1 is displaced from the protein by drug 2. Then how much percentage is free now of drug 1? Previously it was 2 and now it is increasing by 1 percentage. Then 3 percentage. Are you getting it? Hello. Can you hear me?
Yes, yes, hearing.
Okay. So previously 2 percentage was free and now it is 3 percentage. Then what percentage increase is there? It is 1, right? The increase is 1 percentage. So uh, the percentage increase is, if we apply the unitary method, then there is an increase in the free drug of the 50 percentage. So our statement is true. Okay. So if previously it was 2 percentage free, now now it is being the 3. So 3 minus 2 is 1. So 1 is increasing upon 2. Then on 100 it is increasing by the 50%. Okay. So we are moving to our next question. Okay. So what is the structure is given here? It is ibuprofen. Can you tell me what is the function of ibuprofen? Anybody? Any use of ibuprofen? It is a very known drug. Okay, it is a non-steroidal anti-inflammatory drug that is used to relieve the pain. Like it can be used as the painkiller one. So what is provided in our question, that ibuprofen, a weak acid in the stomach, will be present in what given form? So ionized form mostly, non-ionized form mostly, half ionized and the half uh, non-ionized, and will form aggregate. So what is the answer? Anybody?
Non-ionized form.
Why? How can we explain it that it will be in the non-ionized form only? Why not ionized or half ionized or half non-ionized? Okay, for that we need to know the pH pH stomach. So can you tell me what is the pH of the stomach? Approximate pH, means it is acidic or basic? Yes, acidic. Absolutely right. Yes, 1 to 2. It is around 1.5. right? In stomach, what kind of substances is there? What is the reason of its acidity? It is a highly acidic one. It is due to the gastric juice. Have you heard about gastric juice? What is gastric juice? Anybody? What is the main component of gastric juice? Why it is so much acidic?
Due to presence of hydrochloric acid.
Yes, yes, exactly. Due to presence of hydrochloric acid in gastric juice, it is so much have the very highly acidic and have very low pH value. So in stomach, around the pH value is around 1.5. And in the question itself, it is given that ibuprofen is a very weak acid. So how does weak acid dissociate in the very high acidic medium? Okay, so this is the basic dissociation of an acid. It is H. H plus is the hydrogen ion concentration, and it is its conjugate base. So what does happen in case of the in presence of the strong acid?
The reaction means proceeds towards left hand side. That means it's remain on ionized.
Yes, exactly. Very good. So in case of the when it is the have a very low pH, means very highly acidic concentration, then already in medium the H plus ion concentration is very high, right? That is why the pH is so low. So according to La Chatelier principle, when this concentration, this H plus concentration is very high, so to maintain the concentration, the equilibrium will move towards the left hand side, that is towards the non-ionized form. Ha will as a whole become the non-ionized one, as it is a very weak acid, and that is why the ionization of this ibuprofen, that is of this carboxyl group, will be very less. That is, the compound will maximum amount remain as the non-ionized form mostly. Okay. Okay, let's move to our next question. Okay, which of the following reactions is not a phase 1 metabolic transformation? Okay, so can you tell me what is phase 1 metabolic transformation? In brief, not very specific, just what is the meaning of this phase 1 metabolic transformation? This is definitely a metabolic reaction, that is a chemical reaction takes place in our body. But what is the significance, in characteristic significance of this phase 1 transformation? Okay, so phase 1 metabolism consists of the reduction, oxidation or hydrolysis reaction. These reactions serve to convert lipophilic drugs into more polar molecules by adding or exposing a polar functional group such as NH2 or OH. So in this kind of reaction, a more polar group is taking place. Okay, so if we consider the reaction mentioned here, so reduction of the ketone, what kind of group we get via the reduction of ketone? So this is a general formula of ketone, and by via reduction what we are getting? What is the common structure? If we reduce a ketone, then what we will get? Anybody? A hydrogen will be inserted here by after reduction. Then what we call it? The structure? What is this? Anybody?
Alcohol, secondary alcohol.
Secondary alcohol, yes. So according to our definition, that introduction of the NH2 or OH, it is becoming a polar group from ketone. This was the non-polar one, and after the reduction of the ketone, it is being more polar or less polar? This one, after reaction from ketone to alcohol, it is becoming more polar or less polar?
More
Yeah,
polar, more polar.
more polar, definitely. A OH group, a phi hydroxyl group is introduced in this structure. So definitely it is becoming the more polar one. Okay, if we consider this one, oxidation of the alkyl group, then what we will get after the oxidation? Suppose we have this structure, very arbitrary I am saying. So if we are oxidizing this one, so what we will get here? CH3, alkyl group, and after oxidation we will get a free carboxylic acid as the end product. Okay, so from alkyl group to carboxylic acid, it is becoming more polar or less polar? From alkyl CH3 to COOH. Definitely it is polar one in comparison to the normal alkyl group. The carboxylic acid group is definitely polar. Okay, is there any doubt? Hello?
Yes, yes.
Okay,
No doubt, sir.
okay. Then in ester hydrolysis, what we get as the end product after hydrolysis? We get two products after ester hydrolysis. What are those? So in ester hydrolysis, this bond is broken. So we get plus R dash O H. So we
Alcohol.
are getting an acid
Al-
and an alcohol. So is this with respect to the ester, the acid and alcohol is polar or non-polar?
Polar one.
Polar one. So all three reaction, this one, and this one, we are getting that starting from the non-polar compound, we are getting a polar one. So is this a phase one metabolic reaction or not?
Phase one reaction.
Yes, definitely these are the phase one metabolic transformation. But in case of conjugation of alcohol, we are starting from the alcohol more polar one and we are ending up with a conjugated product. Means O, then another some group is there. So this is basically non transforming to a non-polar group. So this is not a phase one metabolic transformation. Okay, this reaction also often create active metabolites and which is beneficial in activating pro-drugs into their active and therapeutic state. Phase 1 include the use of the cytochrome P450 system found in the membrane of the endoplasmic reticulum. If the P450 system becomes inhibited in any way, the drug level will increase and vice versa. If induced, the drug level will decrease. So it is okay that all other three reaction we are getting a polar compound, polar substrate starting from the non-polar one, but in case of the conjugation to alcohol, we are getting from polar to non-polar one. So this is the exception one and not a phase one metabolic transformation. Okay.
Yes, sir.
Yes.
Okay. Okay. What type of infection could be orally treated with a highly polar antibacterial drug? Tell me, it is brain infection or kidney infection or gut infection or lung infection.
Gut infection.
What is gut?
Large size particles.
Sorry. Okay, gut is the GI tract, our GI tract, gastrointestinal tract. So that we generally refer to as the gut. So any kind of infection occurs in the gut wall, we call it as the gut infection. Okay. So what type of infection could be orally be treated with a gut infection? So why so? Now, a highly polar antibacterial drug will not be able to cross the gut wall since it will not be able to pass through the hydrophobic cell membrane. It will therefore remain in the gut and can be used to treat the gut infection. Okay, so as in our question it is mentioned that it is a highly polar um antibacterial agent. So as it is not able to cross the hydrophobic cell membrane, so it will can use the it will be restricted in the membrane and can be used to treat the antibacterial agent. Okay. Okay. So in the next question, cytochrome P450 enzyme and epoxide hydrolase enzymes are involved in the metabolic transformation of an alkene and aromatic groups to diols. True or false?
Yes, it is true.
Okay, let's see how does it work. So here in the here cytochrome P450 enzymes catalyzes the formation of an epoxide. You know the structure of epoxide? Anybody?
Three-membered ring containing oxygen atom.
Yes. So from in the question we are getting that alkene is there. Okay, so when some alkene is there, then with the help of this enzyme cytochrome P450, this is epoxide. So from the alkene, this is a characteristics of this alkene. When there is a alkene, then via the when or some source of the oxygen is there, then with this kind of mechanism, a three-membered cyclic ring is formed, and we call it as the epoxide one. Then it is telling that then after epoxide hydrolase will take place. Then when this one of these two bond, it may break here or it may break here. Some mechanism is there. It is can be acid catalyzed or base catalyzed. Then two OH coming takes place. So and this is 1,2 diol. Okay, so via the cytochrome P450 enzyme, it is forming the epoxide ring, and via the epoxide hydrolase, then catalyze the hydrolysis of the epoxide to form the diol. So this statement is
True.
true. Any doubt, anybody?
No, sir.
Okay, then we are moving to our next problem. Okay, so in the question, it is given that which of the following statement is the closest description of the phase 1 metabolism? Okay, so phase 1 metabolism. So what is phase 1 metabolism? Okay, so phase 1 metabolism includes introduction of a polar group to a drug. Okay, so it is saying that okay, in the second option, it is saying that reactions which occur in the blood supply. So, is this true or false?
False.
Okay, this is false because most of these phase 1 reaction take place at the liver. Okay, not in blood supply. Most of this reaction takes place in the liver. So, in the first option, it is saying that reactions which add a polar molecule to a functional group already present on a drug or one of its metabolites. So, is this true or false? for the phase 1 metabolism? This is phase 2 metabolism. This definition is phase 2 metabolism. Okay, so what it is saying in the phase 2 metabolism, where a polar group, polar molecule is attached to a polar functional group already present on a drug or placed thereby. So this is the example of the phase 2 metabolism.
Phase 2.
Yes, and as we have already mentioned, that reactions which occur in the gut wall, no, it is mainly phase 1 metabolism takes place in the liver. So that is why only the closest option which matches to our statement, question statement, is reactions which add a polar functional group to a drug. This one. Okay.
Yes.
Okay. Okay, so it is saying that which of the following enzyme is not involved in the catalysis of the phase 1 metabolic reaction? Not involved. Please note it. Not involved. So what is the basic condition of the phase 1 metabolic reaction in one sentence? Introducing a what
So
kind of
polar group.
polar group? Okay, so we try to assess the function of these enzymes one by one, so we can find that which one is not involved in transferring a polar group. Okay, so at first there is a flavin containing monooxygenases. So is this catalyzing a phase 1 metabolic reaction?
Yes, sir.
Yes, this catalyzes the various kind of phase 1 reaction. Then monoamine oxidases.
Yes, sir.
Yes, this is also catalyzing the phase 1 reaction. The monoamine oxidase catalyze the formation of the aldehydes from the primary amine. Now esterases, esterase from the name itself, it is uh, catalyzing the hydrolysis of the ester. And we have already discussed in this previous question that in hydrolysis of ester we are getting two components, acid plus
Alcohol.
alcohol. So both of them are the very polar group. So it is from the esterase, it is also involved in the phase 1 metabolic reaction. Then what is the function of this enzyme?
Produce highly polar functions.
Actually, this the function of this glucuronide transferase catalyzes transfer or attachment of a sugar moiety into a polar functional group. Okay, and this is a conjugation reaction, right? We discussed in the first question that which is not a phase 1 catalytic reaction. So what was the question there? Alcohol conjugation. So this is kind of that reaction, conjugation reaction. So what it is doing, It is attaching a sugar moiety to a polar functional group. So this is not an example of the phase 1 metabolic reaction. So our correct option is
Glucuronyl transferase.
transferase. This is not an example of the phase 1 metabolic reaction. Okay. Can we move to the next question?
Yes.
Okay, so here our next question is a P450 enzyme. So let's see how does it look, P450 enzyme. So what we call this one, this cage system, this present in the various kind of biologically active system. What we call this? This is the tetrapyrrole system, conjugated one. This has a very common name. What is it?
Porphyrin.
This is heme group. So, what is not true about the cytochrome P450 system? Okay, they belong to a general class of the enzyme called monooxygenases. Is this true or false?
True.
This is true. There are over 30 different cytochrome P450 enzymes. Is this true or false?
True.
So, variation in the cytochrome P450 enzyme profile between individuals can explain the individual variation in the drug susceptibility. Is this true or false?
It is also true.
Yes, this is also true. Then what is the wrong here? They contain heme and magnesium. So what is the correct statement?
Heme and iron.
Heme and iron. Here in center, Fe2 is there, right? Not magnesium. So here when the Fe2 plus ion is there, then it is coordinated with the 4 pyrrole nitrogen atom in the center and stabilizing the structure. Okay, so it is not magnesium, it is Fe. So this is the not true regarding the P450 enzymes. Okay, is this okay?
Okay, okay.
Okay. So which of the following is one of the rules in Lipinski's rule of 5? So tell me which is the right one. We will consider one by one. Okay. So in our first statement, it is saying that the molecular weight equal to 500. So is this true or false?
True, sir.
Sure.
Molecular
Yes,
weight
sir.
is
Either
less than 500, na? Less than 500, na,
Less than,
sir?
less than 500.
Hmm.
Molecular weight should be less than 500. Yeah, it is not practicable. Na? Molecular weight, if it is equal to 500, then each and every drug should be of 500 molecular weight. Right?
Right.
So this is not practicable. So the molecular weight should be less than 500. Okay, then second one, no more than 5 hydrogen bond acceptor groups. Is this true or false?
No more than 5 hydrogen bond donor groups.
Donor
It
group,
is
exactly.
not accepted.
This is false. This is also false. And in the third one, it is written that no more than 10 hydrogen bond donor groups.
It should be acceptor group.
Acceptor.
Acceptor group, yes, it is. Yes,
Acceptor.
acceptor. This is reversed. This one and this one is reversed. Right?
Yes, sir.
So all the past three statements are wrong. So definitely the fourth one is our
Follow the
right
Lipinski rule.
answer. A calculated log p value less than plus 5. Okay.
Yes, sir. It is a calculated log p value is greater than plus 5, na, sir?
Mm,
Uh, According to World Drug Index database, right, sir. Log p value is less than 5. Correct, sir.
less than plus 5. Yes. This is the right
Less,
one.
less than plus
Yes,
5.
yes.
Okay.
Yes, yes. So we are moving to our next question.
Yes,
Which
sir.
of the following groups is least susceptible to cytochrome P450 enzyme? Tell me. As we have seen the structure of P cytochrome P450 enzyme, what we seen here that it is has very much bulky group, right?
Hmm.
This cytochrome P450 is very much bulky one. So this is a hint of this next one. So tell me which one is the probable answer. It is terminal methyl group or allylic carbon or benzylic carbon atoms or quaternary carbon atom.
Definitely a quaternary carbon atom.
Yes, because of the steric reason. Okay, so terminal methyl groups, when a methyl group is terminal one, then it is sterically very much free. Right, it is very much in the less hindered condition. Allylic carbon also, and benzylic carbon is attached to only one, this one, right? Benzylic means this one. So quaternary carbon atom, when carbon atom is attached to four different large group, then it is very much buried inside the structure, and due to the steric hindrance, it is not acceptable, or this is not approachable to the cytochrome P450, a very large cavity of the porphyrin moiety. Okay, so this is very much difficult to approach in this very sterically hindered site of this quaternary carbon atom. So what is our right answer? This one, quaternary carbon atom. Okay.
Yes.
Okay. So let's move to our next question. So what is written here? Benzene is a suspect carcinogen since it is oxidized by cytochrome P450 enzyme to an electrophile epoxide. As a result, benzene has been largely replaced by toluene as a solvent. Toluene is also oxidized by cytochrome P450 enzyme, but the metabolite is less toxic and rapidly excreted. Why is the metabolite rapidly excreted? So tell me why. Benzene is very much carcinogenic. So as you know that in many country that use of this benzene is banned.
Ma'am.
Yes, basically in Europe and American countries, use of this benzene as a solvent is not accepted. So in replace of benzene, what we use? Toluene. What is the structure of toluene?
CH3 methyl group is attached to benzene ring.
Yes. CH3 group is attached to the benzene ring. So now tell me, what is the advantage of using this methyl group in the benzene ring?
Uh, Toluene is readily metabolized by cytochrome P50.
To what? What is the metabolite form?
Due to
Any
its
idea? Anybody?
hydrophilic.
Toluene is oxidized. I have already mentioned in some previous question. The alkyl side chain is here, and in question it is said that it is oxidized by cytochrome P450. And when an alkyl side chain is oxidized to what kind of group?
Acid.
Yes, very good. And what we call it? This structure?
Benzoic acid.
Benzoic acid. So what happens when we use toluene instead of benzene? Then via the oxidation, this benzoic acid is formed. And as we know that this is a very polar or non-polar group. This part,
Po- Polar group.
very much polar group. Carboxylic acid group is present here. So it is readily excreted by the kidneys. It is absorbed as this is the polarity of this group. It is very much excreted by the kidneys, and it is passed from our body. So from the first two options, rapidly excreted by the kidneys, there are two forms. It is hydrophobic and the hydrophilic. So this is hydrophilic, right? And rapidly excreted by the kidney. And in another two options, there are present that excreted by the lungs. So for the excretion by the lungs, the compound must be volatile. Any kind of gases or anything what we can excrete it from the lungs, right? So benzoic acid not is a not volatile one. So this lungs option we can exclude, and it is forming a hydrophilic metabolites and excreted by the kidneys. Okay.
Yes.
Okay. Any doubt?
No, sir.
Okay. Okay. How can advantage be taken of the blood-brain barrier in the drug design? Drugs can be made more hydrophobic such that they act in the brain and not periphery. Drugs can be add more hydrophilic such that they can act in the brain and not in periphery. Drugs can be made more hydrophobic such that act periphery and not in the brain. Drugs can be made more hydrophilic such that they act periphery and not in the brain. Okay, so drugs can be made more hydrophilic such that they act as the periphery and not in the brain. Drugs can be made more hydrophilic if their target is in the peripheral system. This prevents the chances of the central nervous system side effect. Increasing the hydrophobicity will increase the level of the drug entering in the brain, but it is not possible to make a drug completely selective for the brain since those drugs can still escape blood vessels in the peripheral regions. Making a drug more hydrophilic will decrease the chances of it entering the brain. Making it more hydrophobic will increase the chances of entering the brain. So our right option is we can make the drug more hydrophilic so that can remain in the periphery of the brain. If we made it more hydrophobic, then it can enter in the brain. So in this way, we can take in the advantage of the blood-brain barrier by making it hydrophilic, so it can act as the periphery and not in the brain. Okay, so it is clear.
Sir, in the 11th question, uh, in 12th question, sorry,
Hmm.
it's option 1. Drug can be made more hydrophobic such that they can act in the brain, not in the periphery. It can also be true.
You are saying that one option A can be the answer, right?
Yes, it can be.
Uh, Actually, if we made it hydrophobic, then it will cross the
The
blood-brain barrier
blood-brain barrier. Yes,
and coming to the brain, not in the periphery of the.
yes.
Okay. So to make it more selective one, we are making it in is the hydrophilic one, such that it act as the periphery and not in the coming to the brain. So if we made it more hydrophobic, if our target is the peripheral system, this selectivity is less in case if we make it more hydrophobic, because some of the drug will also be remain in the blood vessels. In that way we are making this design.
But if we make the hydrophobic, then it cross the blood-brain barrier and act in the brain more than in periphery.
We are trying to, yes, we are there, it is periphery na?
Yes. So it's, I think, in the concern of the blood-brain barrier, option A is also true.
Mm, yes, drugs.
Because it's hydrophobic and it's goes in the brain and not
Mm,
available in the periphery.
yes.
And fourth one is also true. It is hydrophilic, not enter in the brain, so available in the periphery. So both are right, I think.
Hmm. Yes, the framing is somehow confusing of this question, how it is framed.
Yes, sir.
So basically, yeah, your concern is right. So if that way, we can also monitor or design our drug so that it can come to the brain and work better, better efficiency we can expect.
Yes, sir.
Yes, yeah, you are right. Your concern is right. Okay, anything else? Anybody has any doubt? Otherwise, we will move to our next session.
Yeah, okay, sir.
Okay,
Yes, yes.
okay. Thank you for joining. We will meet in our next session.
Yeah, tomorrow will be next section.
No, no, not tomorrow. In the next week, next time, next Friday.
Okay, I think some mail is received.
Yeah, tomorrow is also there is a session. Some another person will conduct this.
Okay,
So two session per week is there.
okay, okay. Thank you.
Okay, okay.
Thank you.
Thank you.